Okay, the intermediate value theorem. It really is a common sense theorem. The intermediate, in the middle value theorem. The intermediate value theorem says this: if you have a continuous function, okay, and this continuous function, it starts at 5 and it ends at 7. It's the y is 5 and here the y is 7. The intermediate value theorem says something that we know intuitively. It says that I can't get from 5 to 7 on this continuous function unless I go through every number in the middle. So we know that 5 to 7, to go from 5 to 7, at some point, in case this particular function right here, we know the function had to hit 6, because I can't go from 5 to 7 without hitting 6 on a continuous function. That's all the intermediate value theorem says. It's like if you're driving in a car and you go from 0 to 60 driving your car. Well, at some point you were going 43 miles an hour. It might have only been for a split second, but you were going 43 miles an hour for a very brief period of time. And that's all the intermediate value theorem says. Now we say it in a more fancy way. If f is continuous on the closed interval AB, closed interval, so no open endpoints, closed endpoints, and n is any number between f of a and f of b. So f of a was 5, f of b was 7, with f of a not equal to f of b. The reason we need that is because the endpoints can't be equal, because then there's nothing in between them if they're equal. So it doesn't work. If that's true, if it's continuous, and the number we're searching is between f of a and f of b, then there exists a number between a and b where f of c is n. Okay, so let's do an example. Show that there's a root of the equation 4x cubed minus 6x squared plus 3x minus 2 equals 0 between 1 and 2. Well, a root, or a 0, it's where y is 0. Where y is 0. So in other words, I'm looking for a spot between 1 and 2 where y is 0. Well, if y is going to be 0, if I can show that one end of the interval is negative and the other end of the interval is positive, okay, because a root, or a 0, if this is 1 and this is 2, there's only a couple things that could happen here. Okay, the graph could go like this. If it's continuous, the graph could go like this. And then I'm in the positives at 1, and I'm in the negatives at 2. Or the graph, if it's continuous, 1 to 2, could go like this. It could be in the negatives here and then get into the positives over on that side. And that would be, here would be our root where y equals 0. So what we do is we show, okay, plug in 1. Let's see what we get. Plug in 1 to this equation. First of all, it's a polynomial, so we know it's continuous because polynomials are continuous on all real numbers. So we plug in 1, and we do the math, and we end up with negative 1. We plug in 2, and we do the math, and we end up with 64. So we went from a negative to a positive. Okay? So now we always put this work down to show what our endpoints are. And then we're going to do the math. We did the math. Now we're going to make our explanation. F is continuous because it's a polynomial. We always have to state that it's continuous. Okay? And f of 1 is less than 0. F of 1 was negative 1, less than 0, which is less than f of 2. Thus, by the intermediate value theorem, because the two endpoints capture the number in the middle here, this number is 0's in the middle of the two endpoints. And notice I wrote it f of 1 and f of 2. I did not write the negative 1 and 64 because I want to connect what I'm about to do next. Okay, so f is continuous because it's a polynomial, and f of 1 is less than 0, which is less than f of 2. Thus, by the intermediate value theorem, there is a number c between 1 and 2. Here's why I did f of 1 and f of 2, because I want it to be between 1 and 2, where f of c equals 0. Okay. All right.